about the next part in the digital communication system, that is nothing but the basics of the sampling. In the basics of the sampling, before seeing the basics of the sampling, first we see what is the importance of the digital transmission. The digital transmission refers to the transmission of the digital signals between the two or more points in the communication system. And if the original signal is the analog form, and then it is needed to be converted into the digital pulses prior to the transmission and converted back to its original analog signal in the receiver. The conversion of analog signal to digital pulses is known as the waveform coding techniques. It is the waveform coding techniques, and the digitized signal may be in the form of the binary or any other form of the discrete level or digital pulses. Then for here the basic communication system, or in the PCM encoder system, as we see in the earlier lecture, here is the analog signal. That analog signal is given to the sampling. Here is the samples, the number of the pulses, means this is the baseband signal, and with the help of this baseband signal we have able to convert it the palm signal having the 1 2 3 4 5 6 7 8 9 pulses, and that 9 pulses is a quantized, is approximate value, and that approximate value should be encoding to come the digital data. This is the basically process of to convert the analog signal into the digital form, which is called as the encoding or waveform coding techniques. Then advantages of the digital transmission, just to go through the review of the advantages of the digital transmission. That is the noise immunity. The noise immunity is the first, because the digital system having the more resistive to additive noise, as it uses the signal generation rather than the amplification. Then error detection and correction, it having the error detection and correction capability, because the digital circuit are the less susceptible to the distortion and interference due to the two levels. Transmission errors can be detected and corrected easily, and the probability of error is less. Then it is the easy of the multiplexing, because many baseband signals can be combined and transmitted using the time division multiplexing. Then next advantages is that the integrating the analog and digital data. Then use of the signal generators, they samples the received noisy signal, and it is the reproduce an entirely the new digital signal with same signal to noise ratio as that of the original transmitted signal, so that the signal can be transmitted to longer distance. Then the data integrity. The data integrity is the one of the advantages of the digital transmission system due to the signal regenerator or the digital repeaters. Then data security and the advancement of the digital technology, such as the miniaturization, less power, then it will be consumption, less cost, it is less power consumption, less cost, less weight, etc. Then disadvantages of the digital transmission, because every system having the advantages the same way the disadvantages, which require the more bandwidth. Then it requires the precise time synchronization between the clocks used in the transmitter and receiver. Then it is need for the additional complex circuitry for encoding and the decoding. Then quality of the service can be degraded all of a sudden for very good to very poor if the SNR drops to the specified threshold level. Then we move the modulation. Basically the modulation is categorized into the two part. We know that is the analog modulation and the digital modulation. Then analog modulation is basically categorized, because that part you already know that is the amplitude modulation, frequency modulation, phase modulation. In the digital modulation, that digital modulation is categorized into the amplitude shift keying, frequency shift keying, and phase shift keying. In case of the analog modulation system, whatever the signal is in the form of the amplitude, frequency, and phase. The same way in the digital modulation system is also, it is in the form of the amplitude. Here to measure the amplitude for logic 0 and logic 1. Here is to measure the frequency for logic 0, logic 1. and here is to measure the phase when the transition between 0 to 1 and 1 to 0. Then in the ASK and PSK, in case of the voltage, here is the input modulating digital signal, its value is 1010, and here is the carrier signal, and you put this digital data on the carrier and it will be moved using the shift keying techniques, that is the amplitude shift keying technique, frequency shift keying technique, then phase shift keying technique, etc. In case of, then my dear students, you just understand here, once the digital data 1 is transmitted, at that time the carrier is present, and if the digital data 0 is transmitted or present, at that time your carrier is absent. Hence it is called as the on-off keying, OOK. It is also called as the OOK signal, that is on-off keying signal. But this technique is rarely used, because of that it having the probability of error is more as compared to the frequency shift keying technique and phase shift keying technique. Then here just you observe, in case of the amplitude shift keying technique, if the logic 1, the carrier is present. In case of the frequency shift keying signal, if the logic 1 is able to transmit it, at that time here T is the minimum. Once the T is the minimum, the frequency F is the maximum. If the digital data 0 is transmitted, here the time is a maximum and the frequency is minimum. If the 1 is transmitted, then here T is the minimum, frequency is the maximum. In this way, the digital data 1 is transmitted, where frequency is a maximum, frequency of the signal is maximum. When digital data 0 is transmitted, the frequency of the signal is minimum. In this way, the data is transmitted in the form of the 1 and 0, which is formatted by F max and F minimum. Then in case of the phase shift keying technique, here due to the transition between 1 to 0 and 0 to 1, its phase is a changes, means 1 to 0, here is the phase is a changes, 0 to 1, again here phase is a changes, means in this way during the transmission between 1 to 0 and 0 to 1, here the phase is a changes, and this is the basically digital modulation techniques. Then this is the one sample speech waveform. Once we are able to speak for 1 second, this is the sample waveforms, and this sample waveforms is in the form of the amplitudes, ASK signal. Just you have to be he, ho, word. In this way, the frequency of the signal should be varying. Then sampling of the analog signal. Then in the sampling of the analog signal, the digital circuit are, why digital? Why we want to the digital signal? Because of that, the first case, the digital circuit are less subject to distortion and interference. Means it is capable to fight the distortion and interference that the analog circuit, because binary digits are operated in the one of the two states, either fully on or fully off. Fully on means it is the logic 1, and fully off means it is the logic 0. Hence it is the meaningful to the disturbance must be large enough to change the circuit operating point from one state to the other, and such two states operation facilitate the signal generation, thus prevents the noise and other disturbances from the accumulating in the transmission. But in case of the analog signal, however, are not the state signal, and that can take the infinite variety of the shapes. And once the analog signal is distorted, the distortion cannot be removed by the amplification. Means once the analog signal is distorted, the distortion cannot be removed by the amplification, because in case of the amplification, the value of the amplitude level will be going to be increases. Then another reason behind it, why digital? Because of that extremely low error rate. Means digital techniques is extremely low error rate, and producing the high signal fidelity are possible through the error detection and correction capability. But similar procedures are not available with the analog. Then in fidelity, the degree of exactness which will something is copied or reproduced. Then another meaning or another reason behind it why digital will be expected, because of that digital circuit are more reliable and that can be produced at lower cost than the analog circuit. So in same case it's having the low cost, because of that while manufacturing of the any digital circuitry or digital card or appliances, it required a very less cost. Less cost means it is the less complexity and easy to troubleshoot. Then analog versus digital performance criteria we have seen. The principal difference between analog and digital communication system has to do with the way in which they evaluate their performance. The analog system draws their waveform from a continuous which therefore forms the infinite set, and that is the receiver must be deal with the infinite number of the possible wave shapes. The figure of merit of the performance of the analog communication system is the fidelity criteria, such as signal to noise ratio, percentage of the distortion, or expected mean square error between the transmitted and the received waveform. Then by contrast of the digital communication system transmit signals that represents the digit, and these digit forms the finite set or alphabets, and this set is known as prior to the receiver. A figure of merit for the digital communication system is the probability of the incorrectly or detecting a digit or the probability of the error. Then we move actual in low pass sampling, because according to the sampling theorem, the sampling frequency is the twice that of the modulating frequency. And suppose that consider the signal g of t, this is the g of t, and it finite energy which is specified for all time. A segment of that g of t is shown in the figure, and this is the signal is continuous in the both time and amplitude domain. Suppose that we have to be sample the GT. Here is we have sampled the GT signal. Here is the G of t. Is the instantaneously at the uniform rate at every ts second. So consequently we obtain that the infinite sequence of the sample space ts, second part of the denoted, that is the G, is the function of n of ts, and n is the take all possible integer value, positive as well as it is negative. Then this is the analog signal, and this is the spectrum of the analog signal having the two band, the W and minus W on positive side as well as on the negative side. Then we refer to the TS, this is the sampling time, TS, it is to be given, and these are the number of the samples 1, 2, 3, 4, 5, 6, 7, 8, 9 according to this signal. That's why it's sampling period which is equal to 1 upon ts, and which as the sampling rate, which is called as the sampling rate. So for obvious reason, this ideal form of the sampling is called as the instantaneous sampling. Then in case of the low pass sampling, we have to be calculated the g of t denotes the signal obtained individually, weighted the element which is the function of n which is equal to minus infinity to plus infinity g of n of ts, and its delay should be generated by the t. That's why t minus n into ts, that will be given, and here is the analog signal and instantaneously sampled version of the analog signal. Then in the low pass sampling, we refer to the g of n of tst. There is ideal sampling signal, and the term here sigma t minus n ts represents the delta function obtained at the time t which is equal to n of ts. Therefore the view of multiplying factor of the g of n of ts which is given by the equation 1.1, which is to be given in this equation 1.1, the value of g of delta of t is given. Then from the definition of the delta function we have g of n of ts which is to be given. Then from equation number 1.2 in the equation number 1.1, then we get that g of delta t which is equal to g of t, then summation of n which is equal to minus infinity to plus infinity delta of t minus nts, which is equation number 1.3, and here is the equation number 1.4, that is the direct combo or ideal sampling function. Then in the from this figure it will be indicated by how to generate the instantaneous sampled value. Means carrier wave is multiplied by the modulating wave, then your information should be carried instantaneously. Then from the equation 1.4, the discrete time sample g of n of t can be viewed as the output samples, and g of t is a modulating wave. Then in low pass sampling, in case of the low pass sampling, from the equation number 1.7, means from the equation number 1.4, here is the 1.4 equation will be given, and here is the from the equation number 7, from this function of that data should be provided to the here. The process of uniformly sampling a signal in the time domain results in the periodic spectrum in the frequency domain with the period equal to the sampling rate, and this can be written as the Fourier transform. Then low pass sampling, how the aliasing should be happen from that way. Here is the spectrum of the strictly band limited signal, and here is the sampled version. Then the sampling theorem. Basically the sampling theorem, the band limited signal of the finite energy that has no frequency component higher than the W hertz. It is completely described by specified the value of the signal instant of the time separated by 1/2 W second. Means a band limited signal is a finite energy that has a no frequency component. Am I clear? Then higher that it is the W hertz. Hence sampling frequency should be twice that of the modulating frequency. Then part 1 of the theorem is performed in the transmitter, and part 2 of the theorem is performed in the receiver. Then for signal bandwidth, there is a W is given in the hertz and 2 W samples per second for signal bandwidth. According to then this is called as the Nyquist rate, and it is a reciprocal of 1/2 W is called as the Nyquist interval. Then energy signal has a value only limited time duration. A signal having only 1 square pulse in energy, there is a signal, and there is signal that decays exponentially has the finite energy. So energy signal, the power of the energy signal is 0 because of dividing finite energy is the infinite time. Then here is the given analog signal with respect to the spectrum of the strictly. Then your frequency should be in Fourier transform. Your frequency, this frequency should be greater than or equal to the bandwidth of that system. Okay, the process of uniformly sampling in the signal in the time domain results in the periodic spectrum in the frequency domain with the period is equal to the sampling rate. I hope that all of you understand how the signal will be sampled, why the digital signal will be important, what is its advantages, disadvantages. That part we have seen here. You please subscribe my channel. Any query, doubts, you please write on my comment page, and you click on the bell icon. Thank you very much.